What is end-to-end query term weighting and why is it important for SEO? With David Cousin. The In Search SEO Podcast is brought to you by Similarweb, helping you build better SEO strategies with digital intelligence, insights and data. Hey, it's David. Why did Google develop TW BERT? And what does term weighting mean? And how does this impact SEO? That's what we're talking about today with a man who's worked with some of the biggest brands in the world and some of the most broken sites in the world. He's currently head of organic at Open International. A warm welcome to the In Search SEO Podcast, David Cousin.
Hi there, David. Good to be here.
You can find Dave over at openinternational.com. So Dave, what is BERT in the first place?
So what is bidirectional encoder representations for transformers is basically what you're asking. So BERT, as everybody actually calls it, is basically a piece of deep learning that's electrical retrieval using natural language processing that Google, a few years ago, starting around 2018, slotted into their existing search engine, which does some important things to actually help expand out what you actually mean by a query, understand what's the important parts of your query, and do a much better job of matching it to documents within their index and showing users results that are more relevant to them.
And how long has it been around and how important has it been to SEO?
So it first rolled out in the USA in around 2018, rolled out further in 2019, and it took a little while to kind of roll out to all languages. It rolled out for English first. And so we kind of started seeing, fluctuations in rankings at different times for different markets as a result. And initially, the results were really good. Initially, it solved a lot of kind of underlying problems. BERT's very good at, understanding not just synonyms, because Google was able to do that before, kind of expand out your term into synonyms in that kind of very kind of straightforward way. It's able to understand things like context. So if you search for chicken soup, BERT was able to understand that you're probably looking for a recipe. So it add recipe as a relevant term to look for in the documents in the index to return as results. So you're much more likely to find the hidden result, which was exactly what you were looking for, but maybe wasn't coming up before because you weren't quite searching for the right terms. I think people initially noticed much better results. So from a user point of view, it was great. From an SEO point of view, it kind of was the start of keyword stuffing being less of a thing and, genuinely a situation where we needed to optimize for intent and optimize for what people were really looking for and really delivering on that.
And does BERT just look at the audience as a whole and what people are likely to be looking for, or does it also look at specific individual user history as well?
So BERT is that part of the algorithm's not really looking at user history. There are other parts of Google's algorithm that does look at user history. What BERT has behind it is a big corpus of training documents. So it's kind of had fed into it the contents of Wikipedia, I think Project Gutenberg and various other kind of documents to help it understand the kind of initially the English language, and later training material for other languages as well was added. So it's able to understand that to get context. And so what it's actually then doing, if we kind of really break it down, is it's actually looking at your query and it's breaking it into word pieces. So if we take unhappily as an example, that's a word, but it would break that down into unhappy and ly. And it's then able to expand out each of those word pieces and to give some weighting as well to the importance of those word pieces. But that's based on kind of what's happened before. But it's also got kind of a ranking loss factor and a feedback loop as part of it as well. So it doesn't do this on an individual basis, but it can see, where people have searched for a term lots of times, what they've actually ended up clicking on, and it's able to learn and tweak how it weights things and how it adapts things based on what people have clicked on in the past to find out, if somebody's clicked on the third result and no one's clicking on the first and second result, it can see that it's not done a great job of showing the right results. So it can adapt in that way as well.
So are there any tools that you can recommend that share the likely context of a keyword phrase that's not immediately obvious? Different tools. Feel free to recommend any tools if you can do.
I mean, to try and replicate what BERT's going to do for a particular term is a tricky thing to do. You'd have to have a big kind of piece of kind of natural language processing kind of going on, and you'd have to have the data on what feedback it's got in the past.
So what an SEO's got to do is just look at the keyword phrase and just understand contextually themselves, what the likely search, what the user intends?
Absolutely. And the best way to do that is just to look at the search engine results pages and to do that on a regular basis, because that does evolve over time. If you're, not sure what somebody's actually looking for when they're searching for something, what the actual context of it is, and obviously in some cases for search, different people are searching for things and there's a mixed intent behind it, so you maybe don't know what the majority of people are looking for, then the best thing is to look at the search engine results page and see what's coming up. And if the first few results are all the same type of pages and, they're, let's say they're all how-to guides and they're really detailed, then that tells you that that's what the intent behind that is. Somebody's looking for something really detailed. They want to understand how to do something as opposed to just wanting a definition of something. But you might see that if you go and then look in a different country, jump on a VPN, jump on something like AWR Search Anywhere extension, that if you look in a different country, the same search might have different results. So it's important to make sure that you're looking for each of the markets you're interested in and understanding, is the intent different? And it might be that right now in one market, even if it's the same language, in one market, if you want to be claiming the feature snippet and you want to be ranking first, you need to write a definition of the thing that people are searching for. Whereas in another market, actually the intent behind exactly the same search term is they want a detailed how-to guide on how to do a particular thing, make a particular thing, etc.
There's so many rabbit holes that I can jump down here, because I'm immediately thinking, okay, well, would you do that on the same web page? Well, if you're targeting different countries, you probably wouldn't. And then you can actually say, can you actually use hreflang because it's different content on different pages there?
I do like to talk about hreflang, so I'd just say very quickly there, yeah, remember with hreflang, it doesn't have to be exactly the same content in the same way as when you're canonicalizing. It can be ostensibly the same on the same topic. Yeah, it can be on the same topic, but meeting a different intent.
So staying on BERT, we now have term weighting BERT. What is term weighting BERT, TW BERT?
So in the same way that BERT was bolted onto Google's existing search algorithm, TW BERT is something that's going to be bolted on, or potentially already has been bolted on, to the BERT part of the algorithm. So Google are basically just stacking up their kind of technology and adding extra things on. So TW BERT, term weighting BERT, is a little bit confusing because, as I mentioned, BERT already has some term weighting within it, but that's on a word piece level. And the reason why BERT works with word pieces is because there's a much more finite number of them. If you kind of suddenly are looking at all of the words that there could be, then there's far more words, in, let's take the English language, for example. So I think BERT's got something like 30,000 word pieces, which is small enough that it doesn't take a huge number of resources and it doesn't take a huge amount of time, which is crucial for search, of course, to actually process somebody's query, expand it out, check it against what's in the index and come up with a ranked list of results. But the problem with that is that when you're looking at word pieces rather than words, then you're missing out on some of the context. And in some cases, you are still getting strange results in Google, of course. And recently, a lot of people have been complaining about the quality of Google search results and that there's a lot of spam there. So things improved with BERT, they're still far from perfect. So with TW BERT, what it's actually doing is it's weighting words or n-grams, and that's what it's able to do. And when we say n-grams, basically we're talking about multiple words together. So a unigram would be one word, a bigram would be 2 words, a trigram would be 3 words. And TW BERT initially has mainly been looking at unigrams and bigrams. But once you actually get to that point where you're looking at 2 words together, that gives a lot more information and context. And as humans, when we are putting a query together, or when we're listening to somebody else put a query straight to us, we understand the importance of, two words together. They have different meaning to those words on their own. And we have understanding of certain words that have more importance within what somebody is saying. The example that was used within the paper that's been published about this term weighting BERT model, which has been developed by some researchers at Google, the example they use kind of quite frequently is Nike running shoes. And the fact that somebody has specified Nike means that's more important. The fact that they've specified running shoes rather than skate shoes, and it's not running gear, it's not running, shorts or anything like that, it's running shoes, is really crucial. And if you're just looking at the word pieces and then weighting those, then potentially when you're matching that against the documents in Google's index, you're matching to things that are less relevant. And that potentially is one of the issues of why Google's results are still not as good as they could be. But of course, Google's got to actually be able to deliver quickly. Now, if BERT had all of the possible, just the unigrams and bigrams that there could be within its database, rather than 30,000 word pieces, it'd be looking at potentially millions of different combinations of words that it would need to understand. And each one of those then has to be linked to other words. So the way that kind of a neural network works in natural language processing is each word piece in the case of BERT is a node, and that then has a relationship to other nodes. And the number of dimensions you have impacts how much processing power and how much space kind of it needs, but also it impacts the quality of the results, because the more links you have to the more words, the more detailed it becomes.
So where does this fit into Google's retrieval model?
So what that allows BERT to do at the moment, it can take the word pieces, it can understand by understanding the relationship between them and other words. It can then look at that dynamically and understand what that means for the relationship between the words in the sentence, and it can weight them at that point, and then it matches them against what's in the index. So those word pieces are matched against candidate documents. So candidate documents are basically ones that do, match some of the words, some of the word pieces. And then there's a scoring mechanism which sits within Google's algorithm. And that scoring mechanism considers things like term frequency and inverse document frequency. So it understands that some terms are quite rare across all the documents in Google's index. And so if they are shown that that's more important, so it then weights those on that side, and then it looks at the weighted word pieces, and then it comes up with a score for the document, taking those weightings and seeing where there are matches between the word pieces between the two.
So how do we optimize for this?
At the moment, the way we mainly optimize for that is we have always tended to focus on keywords. What's going to happen with TW BERT is that rather than matching word pieces against a document, we're going to match n-grams. But the clever way that this paper is able to do that, while still not massively increasing the amount of resource needed or the speed of coming up with results, is it takes the scores for the word pieces and it basically applies those scores for the word pieces to each n-gram, but then it matches the n-grams. So rather than trying to match from Nike running shoes from that example again, to match run and ing and shoe and s against the candidate documents, it's able to look for running shoes, and running shoes is weighted. Therefore, it's much more likely to find relevant documents.
And you think it's likely that Google have already implemented this?
That's a crucial question. I think it is very likely, because the way it's been designed, it's just a small extra step alongside what's already been done by the BERT part of the search algorithm. So it's very easy to implement. They've shown that it doesn't increase the amount of resources needed. It doesn't increase how long it takes to come up with the result. And the results are significantly better. They compared their results in the paper to results for some deep learning models. Ones are not developed considering speed and resource. Ones that kind of, will maybe take much longer to come up with results. But even then, the results are comparable with those deep learning models. and they're significantly better than the results from BERT in terms of, with the research, they knew which documents from kind of the training materials ideally should be the ones that are coming up as results. They labeled those, and then they're able to see the quality of the results, did the right results that should have come up, which are the most relevant to people, actually come up. And much more frequently, they did come up than in the past, and with BERT on its own.
So let's finish off with
the Pareto pickle.
Pareto says you can get 80% of your results from 20% of your efforts. What's one SEO activity you would recommend that provides incredible results for modest levels of effort?
So the thing that a lot of people miss is actually just checking the SERPs. And we've been talking about it today in relationship to BERT and TW BERT, for understanding intent. And Google's just getting better and better at understanding intent, and intent evolves over time. So firstly, check before you actually implement a keyword on your page, before you optimize for it, what people are actually looking for by looking at what Google are actually showing. Otherwise, you're just wasting time. And then if you see that you're losing visibility, check the SERPs again and see if the intent has changed and different types of content are showing, different things are showing in the feature snippet, and be ready to re-optimize for that.
I've been your host, David Bain. You can find Dave Cousin over at obeninternational.com. Dave, thanks so much for being on the In Search SEO podcast.
No problem. Thank you very much.
And thank you for listening. Check out all the previous episodes and sign up for a free trial of the Similarweb platform over at Similarweb.com.